We have a lot to go over today, but the first thing is arguably the most important. Everybody's panicking today because apparently Canvas just freaked out, or Infinite Campus, I'm not sure which. You know how I create a link on Canvas for you to submit your assignments? But most of the time, you don't have to submit your assignments because you're here in person and you just turn them into me and I put your grade into Canvas and you never actually have to snap a picture and submit them. Well, Canvas still marks those as missing, but it doesn't matter because I still give you a 10 out of 10. So even though it says missing, it's not a big deal. Well, overnight, all of those assignments just turned into missing assignments on Infinite Campus. So don't check your Infinite Campus grades, please. You'll just panic. I'm going to go in today. I'm going to go through every single grade. I'm going to fix them all, and it will be fine. But for right now, your grades will probably look like they went down quite a bit. Not your fault, not anybody's fault. We'll get it fixed. Don't panic. Your other teachers might be going through this as well. So, be patient with them too, because we all have a lot of work ahead of us to get this problem fixed. All right, so that said, let's talk about some math now. So we have been dealing this week with standard form and factored form. So this is all covered in your 9.3 packet. You're going to want to get your 9.3 packet out. And if there's anybody who doesn't have yours or can't find it, you can come grab an extra copy. So you're going to need your 9.3 packet and a pencil. And that's really all you're going to need today. So we are going to keep talking about converting quadratics between standard form and factored form. So as a reminder, at the start of class, I just want to repeat the difference between standard form, which is y equals ax squared plus bx plus c, and factored form, which is y equals parentheses x minus h, and then parentheses x minus k. The difference between these two forms, and this is going to sound a little obvious, is that the factored form is made up of factors. So what we're going to do today, which we haven't done yet, is we're going to practice going from standard form into factored form. We already know how to go from factored form into standard form. We do that by multiplying the two factors together. But now we're going to go from standard form into factored form. And in order to do this, we're going to use a process called factoring. Go figure. So I have a definition of factoring here. Factoring is the process of breaking an expression into multiplication. It's essentially the reverse of multiplication. So we have a really easy example we want to look at just to demonstrate this process. If I wanted to factor the number 15, I would need to take 15 and break it up into two things that multiply together to give us 15. So pretty easy example. I can think of two things that multiply to give me 15. How about 3 and 5? So we could rewrite 15 as 3 times 5. That's the process of factoring. That's all we're doing here. We're taking something bigger and we're splitting it into a product of two factors. It's going to be a bit more complicated though because we're dealing with quadratic functions and not with small numbers like 15. So what we're going to do today is a series of examples, and this is going to take us the whole class period. We might even feel a little rushed toward the end, but I'll do my best to explain at least the early problems very step by step. What we're going to do in example 1 is we're going to start by multiplying. Since multiplying and factoring are the reverse processes of each other, it's going to help us to look at multiplication first, and then to look at factoring second and kind of see the connections between the two practices. See the reverse of the process and how it works. I think it'll help us conceptualize it. So let's jump into example 1. First, we want to convert y equals x plus 3 times x plus 4 from factored form into standard form. This is what we practiced yesterday. In order to do this, we have to multiply the two factors together. So multiply x plus 3 times x plus 4. And the way we've been doing that is we draw a 2x2 rectangle, and we put our first factor across the top. So x plus 3 goes across the top. And then our second factor goes down the side, x plus 4. Then we're going to be filling in each box with a separate product. So in the top left box, we're going to take x times x. That'll give us x squared in that first box. Then in the top right, we take 3 times x. That'll give us positive 3x. In the bottom left, we're taking 4 times x. That'll give us a positive 4x. And then finally, in the last box, we're going to take positive 3 times positive 4, which gives us positive 12. So then we need to write this out as a standard form quadratic. So we'll write y equals x squared plus 3x plus 4x plus 12. And as usual, our two middle terms end up being like terms. So those two things are going to combine, and we end up with x squared plus 7x plus 12. So if you're looking up at the screen, you might notice I color-coded this. Let me explain why. I wanted to show you, give you an easy way to trace back where every piece of our answer comes from. Our standard form quadratic starts with an x squared. This comes from the top left box. Our standard form quadratic ends with a positive 12. This comes from the bottom right box. But then we have this piece in the middle of our standard quadratic, this positive 7x, which is actually made up of two different things. It's made up of the 3x and the 4x. So both of these pieces here that I did in blue combine together. They add together to give us that positive 7x in the middle. So on the next step, or on the next part of this example, we're going to do this process but backward. This part, the x squared, that's easy. And the 12 is usually easy. The tough part is figuring out what makes up that 7x, because there are multiple things hiding inside the 7x. So as we do this process in reverse, it's trying to trace the 7x back to the 3 plus 4, back to this. That's really the tough logical part of this problem. So let me model that logic for you. We're going to get into our first factoring example. So look over to the right. We are starting with the standard quadratic, and we want to factor it into the factored quadratic. So the step we use is factor x squared plus 7x plus 12. And I just write this out because I like to use this to take notes, and you'll see what I mean in a second. So I'm just writing some notes to myself about what I need to do in this problem. Because factoring is reverse multiplication, we're basically going to use the same method here. We're going to use a rectangle. We're going to split our rectangle up into a 2x2, but we're working backward. So normally we would start by putting our factors on the outside of our grid and then multiplying to see what's on the inside. But we don't know our factors yet. We're working in reverse. So instead, what we're going to do is we're going to fill in the inside with what we know and then work toward the outside. So we know that our first term is x squared. And we know that x squared comes from, the first term comes from the top left box. We also know our last term is positive 12, and that comes from the bottom right box. So those two pieces of information we can fill in. Now, this middle term, this positive 7x, is going to come from both of these. So we're not quite sure how yet. So we're going to leave those blank for now. Based on what we have filled in, just the x squared and the 12, based on what we have filled in, what do we already know about our factors? Well, take the x squared, for instance. In order to get an x squared in this box, the two things that you have to multiply together to get x squared are x and x. So we know that we're going to have an x on the top and we're going to have an x on the left. That much we can already fill in. The next step is to figure out what numbers to fill in to these two blanks that I just circled. So let's think about what information we have that can help us here. Whatever numbers I put into these two blanks have to multiply together to give me 12. So I'm going to make a list of things that multiply together to give me 12. 1 times 12, or 2 times 6, or 3 times 4. Those are the options that I have. So what if I used 1 times 12? Let's just think about what would happen. Don't write this down because this is wrong, but I want to show you what would happen if we put, I'll do this in a weird color. We'll do this in blue. If I put a +1 and a +12, they do multiply together to give me that green 12 on the bottom right. So that part's correct. But then in the other two boxes, I would have a 1x and a 12x. And when I add these two things together, do I get 7x, which is what I need in the middle? No. Okay, so you're seeing what's going wrong here. These two boxes need to add together to give me 7x. So 1 plus 12 is obviously not going to cut it. So let's go back and reevaluate. 1 plus 12, let's just take that off the list. We know that doesn't work, so we're going to cross that off. Would 2 and 6 work? If I put a 2x here, if I put a 2 here and a 6 here, would these work? No, I see some people shaking your heads no, because that would give me a 6x and a 2x, and those don't add together to give me 7 either. Okay, so I think you guys are getting this. Wonderful. What we need is the 3 and the 4. Can somebody explain to me why 3 and 4 are going to work in this situation? A volunteer to explain the logic to me? I know you guys get this because you knew the other ones wouldn't work. So why does 3 and 4 work? Jaden? Because they add up to 7. So basically what we did here was we found two numbers that multiplied to give us 12, but added to give us 7. And that's a pattern we're going to start to see as we work through these examples today. So we're going to have a +3 and a +4, which will give us a 3x and a 4x in these two boxes. And when we add all of that stuff back up, you get x squared plus 7x plus 12. Great job. So now let's write our answer. Our answer, remember, is the factored form of the quadratic. So we would write that as y equals parentheses x plus 3 and then parentheses x plus 4. So this example probably felt a little bit silly because we already knew what the answer was going to be, right? We just did it on the left-hand side in the other direction. So we knew we were going to get x plus 3 times x plus 4. So now let's test our hand at a problem where we don't know the answer going into it and see how we do. Example 2, we start off with x squared plus 8x plus 15. Our goal is to convert this into factored form. So we're going to factor x squared plus 8x plus 15. I'm going to start by drawing a generic rectangle and cutting it up so that it's a 2 by 2. And now we're going to take the pieces of our quadratic standard form and put them into the rectangle where they belong. The x squared goes in the top left, and the 15, positive 15 no less, goes in the bottom right. We can't really put the 8x in yet because we don't know how this is going to be split up. So let's just go through the logic and figure out what we can with what we know so far. In order to get an x squared in that top left box, we would have to have an x here and an x here. One on the top and one on the left. That's really the only way to get x squared, x times x. Now we need to figure out what number to put in the blanks that I'm circling. And these two have to multiply together to give us positive 15. So let's make a list of options. 1 times 15, and then 2 times nothing, 3 times 5, 4 times nothing. I kind of go down the list of numbers. 1 times what gives me 15? 2 times what gives me 15? Oh, nothing? So that doesn't belong on the list. 3 times what gives me 15? 4 times what gives me 15? Oh, nothing. That doesn't belong on the list. And then once you kind of loop back around, you can stop. All right, so this is our list. Inside those circles that I just drew, we're either going to have 1 times 15 or 3 times 5. How do I pick which one to use? Any volunteers want to talk me through it? How am I going to choose between the 1 times 15 versus the 3 times 5? Joel, can you help me out? I think you're onto something. I can see your wheels turning.
You choose the 3 and 5 because 3 and 5 multiply up to 15 and they add up to 8.
Perfect. I couldn't have said it better myself. I'm going to repeat exactly what Joel said. You're going to choose the 3 and the 5 because 3 times 5 is 15 and 3 plus 5 is 8. So we're going to have a positive 3 and a positive 5, which will give us a 3x and a 5x in these two boxes. My screen is lagging today. There we go. So notice that the two spaces that I filled in with blue, the 3x and the 5x, these two things will add together to give us a positive 8x. That's exactly what we needed. So good job, Joel. We now need to write our answer as a factored form quadratic. So we'll write it as y equals x plus 3 times x plus 5. All right, great job, everybody. Example 3 is going to be very similar. Our goal is to factor x squared plus 9x plus 20. And I'm going to start off with a generic rectangle in a 2x2 grid. All right, so I'm going to quickly go through the logic here. I feel like you guys are picking up on this really well, so I think we can do this problem relatively quickly. The x squared goes in the top left box. The 20 goes in the bottom right box. It's a positive 20, notice that. And then that tells us that for our factors, both of them are going to have to start with x because we need something times something equals x squared. The real fun comes into play when we have to come up with these numbers. So let's make a list of possibilities. In order for two numbers to multiply together to give you 20, your numbers might be 1 times 20, 2 times 10, 3 times anything? No. 4 times 5, and then we get to 5, which loops back around, so we're done. So we have 3 options. 1 times 20, 2 times 10, or 4 times 5. Keep in mind, the number we're trying to get in the middle is 9x. So pick a combination of values from your list that happens to add up to 9x. 4 plus 5 will give us 9, so that's going to work. So we'll do a plus 4 and a plus 5, which will give us a 4x and a 5x, which you'll notice the 4x and the 5x do add together to give us the 9x in the middle that we need. So this looks like a solid factoring. Now we'll write our answer in factored form. So we get y equals x plus 4 times x plus 5. And this question came up in a previous class, so I wanted to make sure I addressed it. If you wrote your factors in the other order, if you wrote yours as y equals x plus 5 times x plus 4, you are correct, okay? It doesn't matter which order you do it in. This is still right, okay? So I don't want you thinking you're wrong if you just wrote it in a different order. Okay, so I want everybody to flip the page and take a look at example 4. In example 4, we're throwing something into the mix that we haven't seen yet. We've got a negative involved. Now, this is going to change our logic slightly. It's going to affect the way our numbers combine. So what I want to do in example 4 is take a step back and look at the multiplication again. And as we're doing the multiplication, look for ways that the negative affects the problem. So follow the negative, see what it does and changes in our problem. So in the first part of example 4, we want to multiply the factors together. And this is just an experiment to see what's going to happen. So I'll do my generic rectangle. Across the top, I'll label it with the x minus 4, and down the side, I'll label it with x plus 2. In the box on the top left, we have x times x, which gives us x squared. In the box on the top right, we have negative 4 times x, which gives us a negative 4x. So notice the negative there. Our 4 was negative, so we ended up with a negative 4x. On the bottom left box, we have a positive 2 times x. That'll give us a 2x. And in the bottom right box, we have a positive 2 times a negative 4. So again, we're going to end up with a minus. This time it's a minus 8. So notice what happened. The negative 4 made all of this negative, essentially, the things underneath it, because these boxes represented places where we were multiplying by a negative, so it's going to make the answer negative. When I convert this into a standard form quadratic, it will become x squared minus 4x plus 2x minus 8. And notice that those two middle terms are going to combine. So we get y equals x squared minus 2x minus 8. So I want you to take a closer look at this minus 2x that we ended up with. The minus 2x was not made up of two numbers added together in the traditional sense. It wasn't like the first example we did where we had 3x plus 4x. Oh no, I shouldn't scroll. Where we had 3x plus 4x and it equaled 7x. 3 plus 4 equals 7. On the example we just did, we had a negative 4x and a positive 2x. And when those two things added together, we ended up with a negative 2x. Because one of our numbers was negative and the other number was positive, when you add those together, you actually get a difference, really, not a sum. The difference between 4 and 2 was 2. And then because the 4 was bigger, you got a negative in front of it. So this is going to change our logic as we factor. So keep some of these things in mind as we move into the next part of the example. All right, so on the right-hand side, the instructions ask us to convert our standard form into factored form. So the way we do that is we factor the x squared minus 2x minus 8. I'm going to start by drawing my generic rectangle, splitting it up into a 2x2 grid, and then filling in what we can from our problem. The first piece of the quadratic is x squared. That goes in the top left box. The last piece is negative 8. That goes in the bottom right box. Notice the negative. So in our quadratic, it's a -8. So we have to have the negative there with it inside that cell in the grid. All right, now it's time to start determining what our factors might be. The first part's easy. X times x gives us x squared. But then the next part might be a little tricky. I need two numbers that multiply together to give me -8. So the first thing I'm going to think about is the negative. If two numbers multiply together to give you a negative answer, then one of those numbers has to be negative, but only one of them. They can't both be negative, because if they're both negative, then they multiply together, you get a positive, right? But since we need it to be negative, only one of our numbers can be negative. So I'm going to actually write that down so that I don't forget later. And now let's think about what numbers we could multiply together to equal 8. The only two options are 1 times 8 and 2 times 4. So I'm going to get this wrong on purpose just to show you what happens. If I hypothetically try to fill this in with an 8 and a 1, I'd get an 8x and a 1x. Now we know one of these would have to be negative. We already decided one has to be negative. If it's the 8 that's negative, I would end up with a -7x when I add these together. So that doesn't work. If I make the 1 negative instead and I add these together, I get a +7x. Notice how both times it's a 7, but depending on which one we make negative, we might get a -7 or a +7 as the sum. So neither of these will work. 8 and 1 is not the combination we're looking for because their difference is 7. But we need two numbers where their difference is 2. So that's where the 2 and the 4 come in. So 1 and 8 didn't work. Let's try 2 and 4. That would give us a 2x and a 4x in our boxes. And we need to decide which one of these is negative. We need them to add together to give us a -2. So the bigger one, the 4x, is the one that's going to have to be negative, which means that it's a -4 and a +2. So we figured out our factors. We've checked ourselves. We've added everything in the box back up just to double check to make sure it's what we started with and it all works out. So now we're ready to write our answer. Our answer is y equals x + 2 times x - 4. And that was an easy example because we knew the answer going in. But let's work on an example now, example 5, where we don't know the answer. We're going to have to find it. So our goal is to convert this into factored form. So our strategy is, well, we need to factor. We factor x squared minus 5x minus 6. So I'm going to draw a generic rectangle, break it up into a 2 by 2, and let's fill in what we know. X squared goes in the top left, and -6, notice it's a negative, -6 goes in the bottom right. So we can start filling in our factors a little bit with the x and the x, and then we have to figure out what goes in the blanks for our numbers. So let's make a list of possibilities. First, pay attention to the sign. Our two numbers have to multiply to give us a -6. So one of them has to be negative, and only one. They can't both be negative, just one. So I'm going to make a note, 1 negative. The numbers that we might be using to multiply together to get 6 are 1 times 6 or 2 times 3. Those are the two options. So let's figure it out. Do I have any volunteers who might be able to tell me which one of these options we should pick from the list? Should we be going with 1 times 6 or 2 times 3? Any thoughts, Grace? That's exactly right. Can you help me understand why? Right? Perfect. So you're thinking ahead. You're thinking both about the multiplication and about where this 5x, this negative 5x, is going to come from. So we can kind of think about both things at once. We're looking for a combination of numbers that multiplies to give you -6, but adds to give you -5. So Grace was exactly right. If we use 6 and 1, and specifically, if we make it a -6 and a +1, we end up with a -6x and a +1x in our other two boxes. And -6x plus +1x will combine together to give you a -5x. Very nicely done. So this problem was actually a little bit tricky. Students mix this one up a lot because 2 plus 3 equals 5. So some students have looked at this example before and thought, well, we need to use 2 and 3 because 2 plus 3 equals 5. But we're not looking for a sum in this problem. We need to find a difference that equals 5, which is why 1 and 6 was more appropriate. And that has to do with the fact that one of our numbers is negative and the other one is positive. Okay, so just trying to point out some patterns here that might help you. Don't forget to write your answer in factored form. And then we're done and can move on. Okay, we have 2 examples left. And in the last 2 examples, I'm throwing even more negative signs at you. In example 6, we've got negatives all over the place. First, we're going to multiply these. And as we multiply them, I just want you to watch what happens with the negatives. How do they interact? What do they change? What does it do in our problem? So look at the negatives, pay attention to where they go. So we're going to multiply x minus 5 times x minus 1. And I'm going to do that using a generic rectangle with my x minus 5 across the top and x minus 1 down the side. So inside the top left box, we end up with x squared. In the top right box, we get -5x. In the bottom left box, we get -1x. But the big surprise is the bottom right box. In the bottom right box, we're multiplying -5 times -1, which gives us a positive, because it's a negative times a negative. So we get a +5 down on the bottom right. So when both of our numbers were negatives, so these are just some things to watch out for, because we're going to have to use this logic in reverse when we're factoring. All right, so let's finish this problem out really quickly. We need to write this in standard form. So I'm going to rewrite it as y equals x squared minus 5x minus 1x plus 5. And then that simplifies to x squared minus 6x plus 5. So there's one more thing I want to point out about this problem. The -6x in the middle comes from -5x and -1x. So since these both have the same sign, the -5 and the -1, when we combine them, they add together. Now, they're negative numbers, so the answer will still be negative, but the 5 and the 1, when we combine it, we get 6. We don't get 4 because we're not taking a difference. We're adding them and we get a sum. A negative sum, but it's still a sum. So quite a few weird things happened in this problem that we're going to have to watch out for. Let's see if we can model the reverse logic over here on the right by factoring x squared minus 6x plus 5. So that's our goal. We're going to factor x squared minus 6x plus 5. And I'm going to use a generic rectangle. We're going to put the x squared in the top left, and we're going to put positive 5 in the bottom right. We can start off by labeling the factors with x's in the front, because we know that we need x times x to give us that x squared. But now we need to figure out what's going to go here and here to multiply together to give us 5. It's a positive 5. So let's think about the signs. If two numbers multiply together and give you a positive number, what do we know about those two numbers? Well, one obvious thing is they could both be positive, right? So the signs on our numbers could be both positive. Is there any other possibility? Is this the only option? I see Ella shaking your head. What's the other option? That they could both be negative or both negative. So make yourself a note here. And you don't have to write it out the way I did. I know this is annoying to have to spell things out like this. One thing that I like to do when I'm doing these problems is I might say they're either both positive or both negative. That's how I might write that out, to just remind myself that we're dealing with the same sign. So taking a look at this middle term, this negative 6x, we have already established that both of our numbers either have to be positive or have to be negative. What do you think they're going to have to be if we need to get a negative 6x in the middle? Are they going to be both positive or are they going to be both negative? Any guesses? You can just yell it out if you know it. Both negative. Thank you. They're both going to have to be negative. They can't both be positive because then this would be positive too. So good call. I'm going to go ahead and cross off half of this. I know they're both going to be negative. All right, so now let's think about the numerical possibilities. The numbers that multiply together to give us 5 are 1 times 5. There's no other choice. There's no other number that you could use. So this makes our job really easy. We know we're going to use two negatives, and one of them is going to be a -1, and the other one has to be a -5. Easy as that. So let's fill out our box just to double check. On the top right, we'll have -1x, and on the bottom left, we'll have -5x. -5x and -1x do add together to give us -6x. So this all works out. So let's make sure we write our answer. Y equals x minus 1, x minus 5. Excellent work. We have one more example left. In example 7, you're using the same type of logic to factor this standard form quadratic into a factored form quadratic. So let's wait for my screen to load. And then why don't you see if you can get this one solved on your own? So spend a minute or two, try to figure this one out if you haven't already. It looks like maybe some people have already worked on it. And I mean, we still have like 10 minutes left of class, so that's plenty of time. Spend a few minutes working on this. I'm going to walk around and check on your work, see how you did, and answer your questions if you haven't. Okay, since you all got this right, every single student got this right, I don't need to explain this problem. You can explain it. So, my goal here is to factor x squared minus 9x plus 18. So, Milani, what should my first step be? Well, after my computer screen loads, of course. Hold on, this is frozen. Okay, here it is. So I want to factor this quadratic. What's your first step? What is the first thing you did? Draw a box. All right, let's start there. And then what'd you do next? Say that one more time. Okay, so you put your x squared in the corner here, and you probably also started like this. Okay, great. Another volunteer, what'd you do next? Jana, you got it right. What did you do next? Put 18 in the bottom right corner. Excellent job. Another volunteer. Step back. So we filled in what we can into our grid. Now it's time to start thinking about, oh no, don't do that. Now it's time to start thinking about what goes here and here. So let's think about our possibilities. Did anybody make a list of possibilities? Or did you guys all just jump to the straight to the right answer? I'm more of a possibilities person. I like to make a list. So I would typically start out by doing, 1 times 18, 2 times 9, 3 times 6, and coming up with a list of possible options. That's what I like to do. Did anybody have, at this point, was anybody thinking about the signs, about the positive signs and the negative signs? Kaylee, were you nodding your head? So can you share with me what your thought process is when it comes to the positive and negative signs? Okay, great. So I think there were two things in what you just said. Kaylee kind of assumes that they either both have to be positive or both negative because of the positive 18. So when we multiply them both together, we get a positive. So they're either both positive or they're both negative. But then you said something really important after that. You said they have to both be negative. And why did you say that again? Because of the negative 9 in the middle. That negative 9 has to come from somewhere. That negative has to come from somewhere. So we need to make sure that both of our numbers are negative so that a negative now will appear in our problem. Great logic. Okay, so we're going to use two negative numbers. And now let's figure out what those numbers are. Are we going to use 1 times 18, 2 times 9, or 3 times 6? Why did you choose 3 times 6?
Because negative 3 plus negative 6 is negative 9.
Great. 3 times 6 is exactly right. So our box ends up looking like this. And you can see that the two blue parts, the parts that I colored in blue, will give us a negative 3x plus a negative 6x, which Sadie just explained, add together to give us negative 9x. That's exactly what we needed in the middle. This all checks out. So make sure you write your answer in factored form. So we'll write y equals x minus 3 times x minus 6. And you guys blew me away today. Excellent job.